Hey, welcome back. This is Mr. P Helps with Calculus on Unit 1, Day number 2. So now we're getting into defining indeterminate limits and finding the limit using different limit properties and laws. So first, starting off with a function notation question. F of negative 3, 1, 2, 3 is negative 1, 2, 3. That is the height when the domain is negative 3. You will notice that both sides of the function at negative 3 are both approaching the exact same height, which is still negative 3. And f, what is the limit at negative 8? So if I find negative 8 right here, so this side is approaching the exact same point of this, and that happens to be a height of negative 8. So all right, that's a quick intro of what we did in the last one. Oh, actually, we got a warm-up continued, sorry. So we do need to talk about this, so we didn't talk about this in the last video, the fact that this little minus sign here means from the left-hand side, whereas this plus sign here means the right-hand side. So if I'm approaching negative 1, which is this domain, and it's going to be, it's not continuous at this point. If I'm approaching from the left-hand side, like the first question's asking, then it's going to be approaching a height of negative 7. But if I am approaching negative 1 from the right-hand side, now this is not an answer, but that's the number that it's getting closer and closer and closer to, and that is what a limit is. It's what it's approaching. It's not necessarily what the answer is at that point. So when it says, what is the limit at negative 1, that does not exist because simply these two are two different answers. All right, so now these are some of the properties of limits. So find a limit as x approaches 5 for x. So now if you just simply relate that to property number 2, you'll see that means the answer is 5. So it basically just means, you know, if it's just x, then obviously the answer is whatever x is. So whatever you plug in for it. So basically it's just constant. And over here, if the limit of pi is a number, it's an irrational number, but it's a number. So that's kind of like this property right here on the top. So if I plug negative 2 in for that, well, of course, the answer is going to be pi because the answer is pi. So it doesn't really matter what the domain is. That's going to be the answer at that. Okay, so this is a constant. Sorry, I know I said this is basically like x. So if we have x, you know, whatever the domain is, the range is going to be the exact same. So this is kind of like the function at 3.14. It's constant. So no matter what domain you use, the height's always going to be pi, no matter what you choose. All right, so now we need to talk about what this indeterminate means. So an indeterminate is like getting 0 over 0 or technically infinity over infinity. It basically means what we're going to do is when we're finding limits of functions, we're going to take the x value that they give us and we're going to plug it in for x and we're going to solve, and whatever the height we get will be whatever answer that we get. But if you get 0 over 0, which is going to happen, it doesn't mean that there's no limit. What it means is that we're just going to have to find it a different way. So either by factoring, by doing rationalization or simplification, and there's some algebra tricks that we're going to use in order to solve those kinds of questions. All right, so looking at this first one, if I plug in 3 for x, so that's 3 squared minus 9 over 3 minus 3. Now, when I simplify that, that becomes 9 minus 9 over 3 minus 3, which is 0, which ends up being 0 over 0. So this is an indeterminate. Because I got that 0, 0. Doesn't mean that there isn't a limit. It just means I'm going to have to find it in a different way. So what I'm going to do is I'm going to say the limit as x is approaching 3. And then I'm going to factor this into x plus 3 times x minus 3. Because literally what this is differences of squares, as you learned in Algebra 1. And then what you notice is that we have a whole at 3. So this simplifies down to just x plus 3. So now we can say the limit as x is approaching 3 of x plus 3 equals, now I'm going to plug it in, 3 plus 3, which equals 6. 6 is the limit at as x is approaching 3 from both the left and the right hand side. It is not discontinuous. All right, so looking at the next one, All right, so this is going to be one of those conjugate questions. This is going to be a little bit trickier. We need to apply a trick. Actually, the first thing we need to do is just plug in our value of x and see if it works or not. Let me not get ahead of myself. So plugging in 4 for x, then we have square root of 4 minus 2. Although I think we all see what's going to happen here. This is 2. 2 minus 2 is 0. So it is an indeterminate. So the limit as x is approaching 4. Now, the way of doing this is to take the bottom, which is square root of x minus 2, which is a binomial, and I'm going to multiply it by what's called its conjugate, which means basically the exact same thing for differences of squares. So if it's minus here, then its conjugate will be plus. If it's plus, then its conjugate will be minus. This only works when you have, binomials like this. So I'm going to multiply x minus 4, and you'll see why this trick works out in the end. And I'm going to multiply both the top and the bottom by that conjugate, which is going to help me eliminate some things on the bottom, on the denominator. Because when I use FOIL, first, outer, inner, last, keep in mind these are differences of squares. First times first is x, because this is square root times another square root. Any times itself is squared. Square roots and squareds are inverses, so they cancel each other out. When I do outers, I get 2 times the square root of x. And when I do inners, I get negative 2 times the square root of x. Well, the point of differences of squares is that the outers and the inners of FOIL will cancel each other out. So then all I have to do is first and last. Negative 2 times 2 is negative 4. All right, now on the top, we still have x minus 4 times square root of x plus 2. Now, hopefully you can see why that trick helped us out, because the x minus 4's cancel. We're left with just square root of x plus 2. So limit as x is approaching 4 of square root of x plus 2. Now I can just plug my numbers in. Square root of 4 plus 2, which ends up being 2 plus 2, which is 4. 4 is our limit. All right, for the next one, I'm just going to plug in 2 for x. So negative 2 times 2 plus 5, that's going to work. Negative 4 plus 5, that's a really easy problem. The answer is 1. So the limit is 1 as x is approaching 2. All right, so this time I'm going to do the exact same thing and just plug in, see what happens. So that's negative 1 to the third minus 3 times negative 1 to the second, plus, I know I'm running out of room here, 4 times negative 1 plus 5. Okay, so the limit as, let me move myself, as x is approaching negative 1. All right, so I'm going to do this one piece at a time. Exponents first. Negative 1 times negative 1 is 1 times negative 1 is negative 1. So that becomes 2 times negative 1 minus, actually I shouldn't put minus technically. So negative 1 squared is 1. 1 times negative 3 is negative 3. Okay, so that works. Plus, okay, so 4 times negative 1 is negative 4, and then the plus 5 at the end. Solve that. I get 2. 2 minus 3 is negative 1. Okay, looks like the answer is 0. That is the answer. That's not an indeterminate. Remember, indeterminates would have to be 0 over 0. So that does have an answer. All right, so this question, if I plug 1 in here, by the way, 1 cubed is still 1. 1 minus 1 over 1 minus 1, and we get an indeterminate. All right, so plugging in 1 doesn't work, so I need to find some other way of solving. So you don't do it a whole lot, but this can actually be factored into x minus 1 times x squared plus, so you multiply them by each other, 2 times a times b, which is going to be just x, 1 times x, and then times itself. 1 times 1 is 1. All right, so it's that over this. And if you FOIL, basically it is FOIL. Let's just multiply all of this binomial times all of this trinomial. You'll get the exact same thing as above. Now you'll see that this cancels out, and we're left with x squared plus x plus 1. Now I'm ready to substitute, and as x is approaching 1, So that's 1 squared plus 1 again. 1 plus 1 plus 1 makes a height of 3. 3 is our answer there. All right, so basically these questions, I'm not going to solve all of these. Oh, you know what? I think I will. So this one can be factored. I think if you put -3 in here, I think this is, let's just say it is indeterminate. So this is going to be x plus 3 times x minus 2. And then you can cancel these out. So this actually is x minus 2. So the limit, this question is actually fairly easy as it's approaching -3 for x minus 2 equals -3 minus 2, which is -5. Now, what makes this question a little bit more difficult over here, number 2, is once again, we have this binomial, and we're going to multiply it by its conjugate, which is h plus 1, square root of h plus 1 plus 1. Which is the opposite of -1. And we're going to multiply the bottom by the exact same thing because anything over itself is 1. So technically, I'm just multiplying this function by 1 as long as I do the same to the top and the bottom. So the limit as h is approaching 0. So now let's figure this out. So this times this basically turns into just h plus 1 because the square roots and squareds cancel out. -1 times 1 is also -1 over. So we have h already times square root of h plus 1 plus 1. All right, now the plus 1 and the minus 1's cancel, and the h's cancel. So you're now left with 1 over square root of h plus 1 plus 1. All right, now I'm ready to substitute. So I'm going to throw 0 in and solve. So that becomes 1 over square root of 0 plus 1, and then add 1. All right, so that becomes 1 over square root of 1 is 1, 1 plus 1, and we are done. The answer is 1/2. All right, thanks again for watching, and I know I did all the examples. I don't always do that, and have a wonderful day. Look forward to the next video.